Interior angles of polygon. We already know that the sum of all the angles in a triangle is 180 degrees. To find the sum of interior angles in a polygon, divide the polygon into triangles. The process is very simple. Look at the quadrilateral. Let's draw a diagonal. The diagonal divides the quadrilateral into triangles. The interior angles in a triangle add up to 180 degrees. Now we multiply the number of triangles in the quadrilateral by 180 degrees. The interior angles in a quadrilateral add up to 360 degrees because the quadrilateral can be made from two triangles. To find the sum of the interior angles in a hexagon, the process is the same as the quadrilateral. A hexagon, when divided into diagonals, is formed by 4 triangles. Multiply the number of triangles in the hexagon by 180 degrees. The interior angles of a hexagon add up to 720 degrees because the hexagon can be made of 4 triangles. In short, to find the sum of interior angles of a polygon, multiply the number of triangles in the polygon by 180 degrees. We can generalize this process to find the sum of the interior angles of any polygon. Let's take a look at some of the polygons to find a pattern or general rule. Now let's complete the table dividing each figure into triangles by drawing as many diagonal lines as we can. The sum of interior angles of a triangle is 180 degrees. The quadrilateral can be made from 2 triangles. Multiplying the number of triangles by 180 degrees, we get the sum of interior angles of a quadrilateral. The pentagon can be made from 3 triangles. Multiplying the number of triangles by 180 degrees, we get the sum of interior angles of a pentagon. The hexagon can be made from 4 triangles. Multiplying the number of triangles by 180 degrees, we get the sum of interior angles of a hexagon. You should notice, for every polygon with n number of sides, the number of triangles is the number of sides minus 2. In other words, the number of triangles is 2 less than the number of sides in each example. You can check it out. The number of degrees inside the polygon can be found by multiplying the number of triangles in the shape by 180 degrees. For any n-sided polygon, the number of triangles is n minus 2, and the sum of the interior angles is n minus 2 times 180 degrees. Exterior angles of a polygon. If the side of a polygon is extended, the angle formed outside the polygon is the exterior angle. Look at the figure. E means each exterior angle. I means each interior angle. Each interior and exterior angle are angles on a line. Then the measure of each pair is 180 degrees. Now consider a polygon with n number of sides. The sum of measures of these pairs is n times 180 degrees. We know how to calculate the sum of interior angles of a triangle with n sides. The sum of the measures of the exterior angles is the difference between the sum of measures of the pairs formed by interior and exterior angles and the sum of measures of the interior angles. Expand the brackets and collect like terms. The sum of exterior angles of any polygon is 360 degrees. Let's see how it works. Examples. Calculate the sum of interior angles and the sum of exterior angles in the following polygons. The first polygon is a pentagon. The number of sides is 5. Take the formula for calculating the sum of interior angles and change n by 5. The exterior angles of any polygon add up to 360 degrees. The second polygon is a heptagon. The number of sides is 7. Take the formula for calculating the sum of interior angles and change n by 7. The exterior angles of any polygon add up to 360 degrees. Calculate the size of interior angle and exterior angle of the following regular polygons. First, let's calculate the sum of the interior angles, as we did in the previous example. In a hexagon, n is 6. Take the formula, change n by 6. All interior angles in a regular polygon are equal. The number of sides is equal to the number of angles. So we can find the size of an interior angle by dividing the sum of the interior angles by the number of sides. Each interior angle of the regular hexagon is 120 degrees. Look at the hexagon. Interior angle and exterior angle are angles on a line. So the interior and exterior angle add up to 180 degrees. Change interior angle by 120 degrees and calculate the exterior angle. Now let's solve the same problem for the regular octagon in another way. We know the exterior angles of any polygon add up to 360 degrees. And all the exterior angles in a regular polygon are equal. Then we can find the size of an exterior angle by dividing the sum of the exterior angles by the number of sides. Each exterior angle of the regular octagon is 45 degrees. Interior angle and exterior angle are angles on a line. So the interior and exterior angle add up to 180 degrees. Change exterior angle by 45 degrees and calculate the interior angle. the interior angle of the regular octagon is 135 degrees. Now it is your turn.